the video. It's pretty fun.
All right, well, I'm going to go ahead and kick it off. This is Camille Grant here at Mayfield, and welcome everybody for joining today. We're going to have a great conversation here with Josh from Google, broadly about generative AI and its impact to the market, not just a perspective from Google, but broadly, Josh brings a real great insight as the generative AI lead, global lead for Google, a lot of experience of various customer scenarios, kind of what's working, what isn't to some extent. And we're going to move fast through the slides so we have enough time for conversation and Q&A. I'm just going to do a little bit of background on Mayfield real quick while we get started. Everybody knows by now Mayfield, we've been around a long time. We just raised our 22nd fund, been doing early stage investing across the enterprise, healthcare, climate is a new area, or planet health as we call it is a new area. Semiconductor is a newly aggressive focus area for us. In fact, these are the 8 major areas. These are the 8 major areas that we're investing in. And of course, generative AI is a big piece of it. And in fact, we announced a new seed fund specifically to help at this inception stage of what we consider to be a major change in the marketplace. These are the stacks, or this is the stack that we consider to be the opportunity from an investment standpoint, all the way down to semiconductor up through co-piloting applications. And we've got a number of companies already in our portfolio that we've invested in. And of course, it's going to get busier and busier with more and more investments. And this is just a simple way to say there's lots to be sort of sorted through in this market. So partly today's goal is to help sort through some of that noise. Let me introduce Josh. I'm going to turn off my slides, let him turn his on. I encourage everybody to use the chat bar to ask your question. We'll politely interrupt Josh and poke him with a question or two throughout the conversation. We are recording this and we intend to share the content from today's presentation with everybody as well. So thank you. And with that, I will stop sharing. And Josh, it's you.
Yeah, sure. Just for logistics. Everybody raise hands with questions as we go?
We could raise hands and we can do chat. So both vehicles here.
So for everybody in the audience today, feel free to ask questions. As much as I love to give slides, I'm happy to make this more of a conversation with you all as we get through this. And I can take us into the details of Google and generative AI. I can give you a little background in the history of how we've gotten here, if that's of interest as well. Maybe we start there. I've been preparing a presentation for later today, and it's pretty interesting on how we got to where we are and Google's role in all of this. A little bit of a history lesson, should be a little bit of fun, take 5 minutes or so, then we get to where we are today. So let me share my screen here. Can you all see this? Okay. Yes, thumbs up. Sorry, I was having to switch screens, so I'm on a small monitor here. Okay, so we're good to go. So generative AI at Google. I think the first takeaway with generative AI at Google is that this is not new to Google. In fact, this is extremely old for Google. It's one of our founding members. You're all familiar with Larry and Sergey. Even in the early days of Google, the concept was that artificial intelligence was going to be how we're going to scale search. That the components were all there as early as back in 2000. The mindset was that eventually we get to close to a generative AI, in order to facilitate search at scale. A little fun. We'll try this. I'm not sure if this will work, but so, let's see if the audio will work for you all. But this is an actual video from 2000. Larry talking about Google. So let's see if this will work for us.
Artificial intelligence would be the ultimate version of Google. So if we had the ultimate search engine, it would understand everything on the web. It would understand, exactly what you wanted, and it would give you the right thing. And that's obviously artificial intelligence. It would be able to answer any question basically, because almost everything is on the web, right? And so we're nowhere near doing that now. However, we can get incrementally closer to that, and that's basically what we work on. And that's tremendously interesting from an intellectual standpoint, right? We have all this data. If you printed out our index, it would be 70 miles high now. We have all this computation. We have about 6,000 computers. So we have a lot of resources available. That we have enough disk space to store like 100 copies of the whole web. So you have a really interesting sort of confluence of a lot of different things, right? A lot of computation, a lot of data that didn't used to be available. And from an engineering scientific standpoint, building things to make use of this is a really interesting intellectual exercise.
I want to know who got him to wear a tie. So,
yeah, especially in 2000, that was the early days for sure. But the reason I bring that up, and I think that that's fun to look at, is that really is the genesis of Google. Very early on, Google put the puzzles, the pieces of the puzzle together to understand that, hey, the core components of artificial intelligence for search are a massive amount of computation. It's kind of funny, he even says in the video, we have 6,000 computers, which is nothing today, but we have 6,000 computers and we have copies of the web. So essentially we have the knowledge base and we have the computation that we should be able to achieve AI in a form or fashion that really we see today from a generative AI perspective. So if you move forward here, it's kind of the timeline of what I see really pivotal events in the formation of where we are today with generative AI. So he mentioned compute, and we had the mindset of let's use artificial intelligence to scale search back in 2000. And all of you are stewards of the internet and artificial intelligence. A big step forward, a big leap forward was in 2006 when NVIDIA released CUDA. And that's a pivotal moment in generative AI and artificial intelligence in general, because that really democratized the supercomputer. Yep. Again, there's a lot of serendipitous moments in our progression into where we are today that, in NVIDIA, I joke sometimes probably they just keep falling into the perfect vertical after perfect vertical after perfect vertical. But so if you remember back in the early 2000s, the 90s, I mean, I knew as NVIDIA as a gamer, right? That GPUs were
Yep.
primarily used for gaming and 3D rendering. But they just so happen to work really, really well with machine learning. With the invention of CUDA, it allowed everybody, universities, companies like Google, to create machine learning supercomputers at scale, that cost effectively. Still expensive, but not a supercomputer, not the craze of the world, not what the supercomputers that were back then. And then the other pivotal moment that I wanted to talk about, again, relative to Google's march down this path was. In 2009, ImageNet was created for vision. So if you can recall, back in the 2009, 2010, there was a lot of work being to try to figure out vision classification with machine learning. And this seems trivial now, but the epiphany moment that Feifei had at Stanford, and she was at Google for a while here, was maybe we just needed a larger training set. And this seems, again, trivial now, but this is the progress we've made as a company to get to where we are, is that that if we had a well-labeled massive data set of images, that maybe we could get a vision model to classify images at the same level as a human. This was a hard task at the time. And so what we did, it was actually a brilliant hack. Because if you think about it, if you wanted to label millions and millions and millions and millions of images, and this is kind of the secret behind machine learning that some people know, and maybe not everybody knows, that there's a lot of humans involved on labeling these training sets before you can even get to the point where the model produces what it needs to. And so if you think about it, back in 2009, let's just say I gave you the task of, okay, I want you to label 10 million images. How would you do that at scale, especially as a student at Stanford? And so the brilliant hack was, if you're familiar with HTML or all the early web, every image on the web has an alt tag. And that alt tag was specifically supposed to be there for accessibility. So if you had a blind user that was surfing the web, the tools that they would use would actually communicate to them via that alt tag what they were looking at. And that epiphany moment, I think this is brilliant. Again, it's one of those serendipitous moments is, oh, we already have every label on the web is already labeled, or primarily a large portion of it. The work's already been done by every developer that ever put an alt tag around an image. And so that data was correlated. Again, this is why Google is so pivotal to this movement is, of course, as Larry mentioned, we had multiple copies of the internet. So that meant we had multiple copies of every image on the internet that was just organically labeled by the development community. So that was a huge step forward in proving out that, yes, big label data gets us to the point where vision classification started to work. And so the next challenge that Google had was when you think about our user base and scaling billions of users across multiple portions of our platform, was language, was text. How do you translate, or how do you create sentiment across multiple languages? And language is really tough. And you can imagine this problem that we were faced with is, hey, we want to create a machine learning model that can translate between any language on the globe and derive context and do that correctly. That's a big task, and it's a very hard problem of, if you think about it, labeling images is pretty straightforward, but context around our written language is very tough. Depending on how you phrase things, it can mean completely different things. Depending on how you place the words, can mean completely different meanings. So you can imagine us looking at this problem and saying, we would need an army of labelers and probably years to get to a point where if we trained it like we did with the vision model, it would be able to translate and predict natural language. And so the brilliance came in, and you've probably all heard about it now. In 2017, the brain team came up with a paper called Attention is All You Need, which is really the invention of the transformer model. So when you hear the T in GTP, that's what this is based on. And without getting into the weeds of the technology, this is, again, was a concept, and we didn't know if it was going to work. That instead of trying to label text to understand translation and natural language processing, what if we just took all the text that was on the internet and transformed them into numeric variables and then look for patterns? And the attention part of that is not just look for patterns for the next word, but also pay attention to the words that were in front that we're trying to compare it to. And then we trained it using what is similar to, I'm aging myself, but if you recall, can you see my presentation okay? It went dark on me.
Yeah, no, it's still good. Yep.
Okay. So the old school Mad Libs, if you're a kid my age, you used to play these games where you would fill in the verbs, the nouns, and make funny sentences. And so what we basically did is we took all the data's conversational text information, we transformed that into numeric values, and then we ran that through the model over and over again, taking portions of the phrases out until the model was actually positioning the right phrase in those sentences. And again, we didn't know if this was going to work, but that is really right there. 2017 is an amazing birth of the generative AI movement. That's really where it started. Because what we found out, and again, I love having this conversation, because when everybody asks me about Google, what's it like working at Google? Early on, one of the epiphanies I had is that knowing all the technology we have and understanding machine learning was applied to pretty much everything you think of at Google. What blew me away is that we as humans, we focus on the 1 or 2% that make us different, or we feel that make us different. But on the whole, we're very predictable. And that's really what this transformer model proved, was that even without context, giving enough examples of how we communicate, just symbolically, we can understand human context, which is, again, blows my mind, fascinating on how we got here. So that was really the last piece of the puzzle to get to this generative AI state that we're at now. Was we now had the compute, we've got massive data centers in order to train these models. We had all the data of the internet to train on. And the transformer was that understanding to recognize those patterns in that deep set of data to get us to the point of now we're having conversations with these models. So we applied these transformers to search in 2018. And as a consumer of search, you may all remember this, but I remember this. There was a pivotal moment within Google search where, as you remember, maybe a decade ago when you went to Google, you had to kind of phrase things right. Like you were basically prompting the search engine to look for what you want. There was an art to Googling for sure. And right around that time, if you try to remember back to 2018, as we introduced transformer models for content analysis and search, which was BERT. And that's when Google really shifted to, I can ask you the question. You know what I mean? Like our whole methodology of using Google search as a populace is very changed. Like now you can go into Google and you primarily you're going to ask it questions and it understands your context perfectly and gets out on it. And that's all based on transformer models that we implemented back in 2018. And it was hard to, you know, again, it was hard to explain to the general populace what was going on because you weren't directly interacting with the generative AI models like we are today, but they were already powering a core part of Google, like the core part of Google back in 2018. So really fascinating. And then, you know, in 2020, we trained a model Lambda, and this is when I first got involved a couple of years ago with generative AI models, was doing some early testing with Lambda. And that's when we had the parameter size high enough where we would measure the response of these models. And we would compare it to human contextual awareness. And right around 2020, I can almost remember the exact day, the exact time that I was playing with this model, where it rivaled human contextual awareness, meaning you could start to converse with it and it was understanding it, your input just as clearly as if I was talking to a human. Humans aren't perfect by any means. We're always asking for clarification on statements, but that was a big epiphany moment for us. And we were very thoughtful around, again, because none of this has been new to us and we've been using transformers in search for a while, but we also understood the challenges with alignment, factuality. So when I get a lot of questions on why Google was slower to the market in this space of releasing this direct to consumers, it wasn't because we weren't already aware. We actually invented and using it. It was because we knew specifically the problems with hallucination and alignment right off the bat. That was one of the big concerns. And for us, as an information company, we were very cautious because we didn't want to erode any trust in Google search. If you think about it, you know, back in 2020, if we would have released this, it would have kind of blew the minds of everybody. And hallucination would have been a very new concept. And what we didn't want is to dispel trust in Google search based on your experience with a generative AI model. But we actually showcased this, and people may remember this in the that are on tonight, but Google I/O in 2020, you may remember Sundar talking to the planet Pluto. There was a demonstration, he talked to Pluto and he talked to the paper airplane, and it fell flat. And it was because you didn't understand how that was created. And all that was, now it's trivial. That was a prompt. That was just Sundar prompting Lambda to say, hey, you're planet Pluto, respond as planet Pluto. And it did it perfectly based on the corpus of knowledge of Pluto. And then he did it with a paper airplane. But it wasn't until the general populace kind of got their hands on it with the advent of like GTP3 that really the zeitgeist kind of experienced it in firsthand. And that's, you know, after seeing the acceptance of the general populace, we then launched Bard and Palm, which I'll talk to now. But that's fun little, I think it's interesting to set the context and how we got here. It's actually been a 20-year journey, primarily led by a lot of Google. And so, you know, we're continuing to innovate on this. One of the things that differentiates us in this field, in this market, is, as you can see, all the way back from 2000, we have to invest in this. We will continue to invest in this because it's the core of how we scale our products. So we're not building foundational models like Bard or Palm to create a new revenue stream for us. These are core to our capabilities for your product, for our direct-to-consumer products. So the investment for Google in an AI perspective is not new, and nor will it slow down. What's new is now we're allowing you to gain access to these models via Google Cloud. You know, direct B2B market on that. And how we bring that is through our platform called Vertex AI. So Vertex AI has been around for a while. It's been our machine learning portion of the platform, of Google Cloud Platform for quite some time. What we've added is some new components around generative AI. So we've added generative AI app builder. We've added our generative AI studio and our model garden. And what this is it's just an easy to consume marketplace for deploying, leveraging models on Google Cloud. Right now, you know, where we have foundational models available in the state of the art is in text, code completion, code generation, image generation, dialogue or chat, audio, music is coming, video. If you're, you know, that's such a hot market right now. I'm all over the video. I'm very interested in where generative AI is going to go for video, so that'll be coming to the platform as well. Again, we're investing these is both for our B2B business and our B2C business. So as much as we serve generative AI through Google Cloud, we're integrated into all of our products as well and have been for quite some time. The way we architect, and this is the reason I bring this up, this is a very big hot button with a lot of our customers as well, is that there's been some early concerns on if I'm going to use this foundational model, is my data being sent to these foundational models, and is it being used, is it being collected and trained to improve this foundational model? For us at Google, we segment that completely in Google Cloud. So we're not using any of our customers' data for training of the foundational model. We actually freeze those weights. And what we do is we segment, if you want to fine tune that model, and again, I'm jumping around the terminology. I don't know what everybody's level of experience with this, so I'm happy to answer questions on fine tuning and embedding. But if you want to fine tune that model, what we do is we create an adaptive layer of neurons that sit within your project. So think of it, you have a DMZ between you and the foundational model. So you can augment the skill set of that foundational model with your own data and your own training that only live within your project. So you have complete control over that.
Josh, it's probably logical for you to actually explain your interpretation of fine tuning versus embedding, just to set the stage.
Yeah. So think of, I've heard this terminology a lot. Think of fine tuning is the persona of your model. So if you want your model to respond in a certain way, not a certain set of data, that's where embeddings comes into play. But if you want your model to respond in a certain way, almost like giving it an accent, it's kind of an easy way to think about it. If I want my model to have a specific accent, or right now, really relevant, if I want it to return a specific set of JSON, that's where fine tuning comes in. So I can give it examples, and not many examples today. It's very different than it was before. A few hundred examples usually gets you pretty close to what you want to be. So fine tuning is the way to have a model respond on what it wants. While embedding is a subset, is augmenting its data set with an additional form of data. So think of it, we have an embedding API as well. So the two together, you can use the two together. So if I want a specific, if I want to use, let's say, Palm to glean me insight on a bunch of internal documents I have within my organization, I'm not going to fine tune the model on those documents. That's not going to produce what I want. That's basically just going to give it it's going to talk like your document, but it's still going to use the data of the general corpus. Whereas embedding, what I would do is take that document, I run it through our embeddings API, which basically creates the same embedding model that we use for our foundational models. It chunks up that data and embeds it. And then what your application does, so if you have an embedding sitting next to the foundational model, then if I'm going to ask a question, let's say, I don't know, I have an internal PDF that's like 100 pages long on how we deal with customers, and I want to ask it a specific question. So what it does is we use our semantic search and embeddings to first query your document, and we derive the portion of the document and the information of the document that we think is what you want. And then that gets circumvented to the foundational model to say, hey, summarize this. So the foundational model is not actually going out and grabbing the information because it wouldn't know and wouldn't have it anyway. It's just going to hallucinate at that point. So embeddings is a step in that process flow of the application development, where first search the corpus of data that's specific that I want you to pull from, and then pass that back to the model to summarize or derive insight out of that context. Very different than fine tuning.
So there's a question here, Josh, from Ruku about how you keep the customer data separate. Ruku, I turned on your mic if you want to ask your question directly.
Yeah. Thanks, Camille. So basically, I just want to understand how you kind of keep the data or the knowledge not going back from the customer tenant into your foundational. And a follow-on question. I mean, thanks for explaining the fine tuning in the last couple of minutes. Learned a lot. The question is around, okay, if every query you are going to do this retrieval and then augmenting with the foundational model, then is that the case that the model really not learning anything because of those interactions? Because every time you are doing the same thing again and again, right? I ask the same question 50 times. 50 times the pipeline is going to go retrieve and do the same thing. So where is machine learning or AI in it?
Yeah, think about it as it's not going to add to the foundational corpus. So we do have human reinforcement learning. Like if you want to do it in that way, you can. But think about it as No, and for a lot of reasons, you don't want the embedding data to be learned by the foundational model, because a lot of times when you're talking about that embedded data, that embedding data, it gets updated. Right. So that's what, we may not get into the weeds here, but that's also where, there's pipelines involved in this as well, because a point in time embedding is easy to do. An embedding that changes on a daily basis, weekly basis, minute basis revolves a pipeline as well. So a lot of cases, a lot of the use cases I find, you don't want it to become a static portion of the corpus of the foundational model, because the embedding data is changing. Like, I'm struggling with that right now. Like, I want to build a model to enable my pre-sales organization on generative AI, but the content keeps updating. So the last thing I would want is the model to embed it all in the foundation portion of it, because it would be stale or would be static, very quickly.
There's another question here from Edward, really asking your opinion, I suppose, on Zoom leveraging all of our content for their own language model. I don't know, Edward, you have turned your mic on if you want to further ask your question. If you want to ask it directly, go ahead. So the question is, what would you say to Zoom, who announced that they would use customer data from our meetings for their own model?
Oof. That's a very
it's going to get scary here. So
yeah, I mean, it's tough, because especially with this, right? Because it's trivial for you to take a recording of a meeting, which we're doing right now, and do a speech to text translation, and then that becomes an embedding doc. And then I could ask, like, hey, what did Roku ask in the meeting again? And boom, it's there. It's like having an assistant over my shoulder. That's keeping real time. But there's a huge privacy concern with that.
Yeah, totally.
And anytime a company is saying, hey, I'm going to train this for their foundational model, would freak me out a little bit, just because inherently the way foundational models work is what goes in can come out. Now, it's usually chunks and pieces of that, but if you're actually training a foundational model that's a shared model, there's a probability that whatever it's being learned on, a fraction of that, or sometimes bigger portions of that, can resurface as an answer within that foundational model. That's some of the press you heard about early on, not with us, but some of the other large foundational models, and some of the real concern around intellectual property with using some of these tools is it being used for the training? And that we're very explicit. That's not the direction we want to go at all. Not unless, and that's why the segmentation, the earlier question too, is so important. That what you want to be able to do is, the way we do it is, think about it as, like, from an old school storage perspective, we're creating a caching layer that sits within your project. So if you want to fine tune the model, or that embedding data we talked about, that all lives within your project and never traverses other than the aggregate question of the foundational model across that DMZ. Now, there is a shared foundational model behind that, and your question does get sent to the foundational model for interpretation, but it's not stored and it's not used for training. That's the big one.
Yeah.
Now, even that, and I get, like, this is where a lot of the sensitivity is around, and why I get asked a lot. Even that is sometimes a blocking point. I get into a lot of times. Sometimes I get into the weeds of how our memory state works, and how long is it in memory when you ask that question. I mean, there's general. And so what I see definitely evolving, because I get asked this quite a bit, is, hey, can I just run an entire version of Palm in my own project? Because I don't want anything being shared. Even if the weights are frozen, even if you tell me that, hey, it's not going to be updated for the foundational model, I want to have complete control over that. And that is where I think things will evolve to very quickly. We've been public about, the reality is, if you wanted to run Palm within your own project, technically you can do it. It's just a very compute intensive, very cost prohibitive model to do it on your own. Now, we've already announced, and we're making efforts, and I think we talked about this before, is, like, the new hotness will be how small you can get these models to perform the base level functions you want. So we're working on that already, all the way down to being able to run localized models on Android. We announced that at I/O.
Nice.
And so eventually, I don't see it being very long, where, depending on the level of functionality from the model, you'll have an option to run the whole thing within your project.
So couple other questions here. Anu George is asking about, how are you going to, what other announcements are coming out? And I presume you've got some slides here coming up on next gen stuff coming from Google that might separate you from Anthropic and OpenAI. But then she's also asking, what's the advantage of embedding? And Anu, you're able to talk here if you want to ask your question on that.
Yeah, great. Thank you so much, Gamil. So Josh, great conversation so far. I think the question I really have is, what is the advantage of embedding? Because the data, even though you created some kind of a cache layer with embedding, you still have data going into the foundational model. So why won't you just allow your data to go directly and have it directly accessed by the foundation model? So can you just help me understand that?
Yeah, so for us, think about it this way, is because for that reason that we don't want your data being stored or our foundational models learning from that data. That's the primary reason you would need embedding when you're using a foundational model. In the future, like that, again, like as these models get smaller and more consumable on an individual basis, you're gonna these parameters are gonna change. Like this, as you all know, this industry is changing on a daily basis. So as things start to get smaller and smaller, you'll have more control over what you want to do. It's just right now these foundational models are just so big. They're great for MVPs and a lot of the high level functions, but most consumers won't be able to host it themselves just at the scale today. But again, like open source is moving so fast. That's something that we can talk about quite a bit, is that.
Yeah, I do want to get to that. Yeah. So another question from Venu, and then I'll stop here with the questions for a moment, let you power through.
No, this is fine.
Fine tuning versus in context learning. And Venu, I don't know if you want to ask your question directly as well. Turned on your mic. But you got to hit the.
I think this is good. This is fine. That question is self-sufficient. Yeah.
Okay, great. So Josh, I'll let you power through some. I know you got some great stuff, and I want to get to some of the other sort of questions around how as an enterprise should be going about building their own environment and lessons learned on some of that front. So.
Sure. And so this slide that I'm showing here is, again, just a visualization of what I was talking about with that adaptive layer. So think of it as from a neural network perspective, we create adaptive layers. To think of it as a caching layer in front of the foundational model. Those are the neurons that you train, that you tune, that sit within your project. So if you look at the flow of communication, like your inference happens both at the adaptive layer and the large model, the foundation. But we don't store any of that in a large foundational model. Is as you see here, the term is called frozen. So none of those parameters change, and none of that data is collected. It's only happening in the adaptive layer that happens within your project. And again, totally understand, like in this model, you control the uniqueness of what you want the model to do. You control the data, whether it's trained on it, those adaptive layers live in your project, but there's still a request being made based on what you've created in your project for context from the foundational model. So there's still a portion of that that's shared, but the overall message that I want to be clear with everybody here, unlike Zoom or anybody else, we're not collecting any of that. We're not using that for reinforcement for learning of the foundational models. So that gets that application, that foundational model gets called for context, summarization, whatever it may be, based on your adaptive layers, responds back, and then that data is deleted. That's never stored, so the memory is cleared at that point. But again, like I get like highly regulatory industries, this may or may not even be a model even today, which is why open source and some of the things we're doing is moving so fast. So let me, I think we're pretty good close to the slide. So again, this is very timely. So again, the big difference for us, for Google, or a couple big differences in us and the other players in the space is, like I mentioned before, one, we're going to make the investment in AI regardless of this market, because we need it for our direct-to-consumer products. Google's not going to slow down an investment in AI. If anything, we're accelerating investment in AI. We're not building a business around these foundational models. Like many things at Google Cloud, we are just exposing internal services that we needed to you in a consumable format on the cloud to take advantage of the same technology we're developing. And so what that means for us, we're also a cloud provider. And so, yeah, it's awesome if you want to use our foundational model, but we have to invest in that anyway. So that's a sunk cost for us. We're not looking to get a return on that investment. So for us, that means we're embracing third-party and open source models too. I think one of the earlier questions is how we compare to some of these other models. For us, it's not so much how do we compete or compare, it's how do we bring them to the platform so you can access them on Google Cloud. It doesn't matter to us whether you're consuming our model or somebody else's model. If it's on Google Cloud, that's a win for us, and we think that's a win for you. So I think we just announced, you may be hearing like publicly, you'll see some big ones announced very shortly. Maybe some meta models up there that's been all the buzz lately. And I was going to say around future announcements, I didn't think about it, but we're kind of in bad timing because we're 3 weeks away from Google Cloud Next. So there's a bunch of stuff we're going to announce that I can't talk about that are 3 weeks away. So
stay tuned on that, I guess.
Yeah, stay tuned on the future announcements because that's happening right around the corner.
So please share all that when you've got it, Josh, and we'll get it out to the crowd.
Yeah, and if anybody's at Next, feel free to ping me. I'd love to have coffee and chat.
Great.
These last 2 slides, and we'll just open it up for questions after this, are really primarily a lot of just my perspective on what we're seeing in both the startup and the enterprise space. So in the startup, from a startup perspective, early days, a lot of building on functions of these generative AI models. And there was really a gated access to these foundational models. So there was some runway for some of these startups to gain market share based on some application of what a foundational model can do to a traditional use case. A lot of content generation, a lot of summarization, a lot of ad tech. And foundation, what we're finding right now, and again, I'd love to open this up for conversation, is that these large foundational models are great for MVPs. It's amazing you can create a product in a few hours with some great prompting, some embedding, some tuning. But they're heavy. They consume a lot of compute. So even at the fractions of a penny these days that they're at the market, at scale, they're becoming cost prohibitive. Depending on if you can pass that value along to your customer. That's the really key in all of this, right? Is that if there's some perceived value you can construct out of using a foundational model that's worth your customer paying that premium for, then that's a sustainable model. But if you're not able to pass that additional cost of the foundational model in your application stack, it's a hard road right now. A model, and this is the other thing that I don't have a slide for here, but I'm going to talk about in a different session later today, is that there's no secret that the computation is powering this renaissance of generative AI, but there's definitely a scarcity of capacity going around global capacity issues. So that's another forcing function, I think, to get into the smaller models. And I say in 6 months, it should probably 8 months now, I need to update this, but we've kind of gone full circle. Last year, when ChatGPT hit, and I was already working in the space, there was a lot of massive seed funding that I've never seen before for a lot of startups to go after the generative AI model itself, like building large foundational models to go to market with as a player or competitor in this space. That what we're finding out and you're seeing in real time in the field is that takes a massive amount of capital, and it's not a one-time capital outlay like that. The problem with these giant foundational models is you could spend a month training them and millions of dollars and to find out that, it needs to be run again, or it's not working correctly. It's a never-ending process. Again, why Google's been investing in this for forever. We know this really, really well. So I've seen a dramatic shift from we're going to build models to now we're just going to consume API endpoints around these foundational models. Almost back to now with the open source movement, and this is what I put in the bullet here, is that open source is going to continue to iterate. And I think what you'll see these foundational models being brought up by the major players like us. Then you'll see the open source community start to come up to parity, hopefully at a much smaller footprint that alleviates some of the strain on the GPU capacity footprint. And then you'll see the foundational models leap again. You'll probably see that, because these models take a while to produce. I would guess every 8 to 12 months, you're going to see these leaps in the foundational models and the open source community constantly trailing them, but in a good way, because you probably won't need the functionality here. You'll probably need the functionality here, which is where some of the smaller and open source models will probably meet your demands at a much smaller footprint, which means cheaper inference, better scale. The other thing that I'm seeing quite a bit of is that early days, and I say early days, 8 months, 9 months ago, but early days in leveraging some of these foundational models in your application stack, there was probably a few API calls per function. But with the advent of like LangChain and a bunch of these, there's a bunch of really cool new libraries out there that are stringing together LLM calls within a higher level function. We're starting to see some performance degradation, meaning if you've got an application stack that's using an API call multiple times throughout every function, you're going to pay the price of the speed of light, unfortunately, if your application does not sit next to the foundational model.
Yeah.
And that's also, it's classic in the cloud space. This was a classic problem that we had with customers that had their data sitting on one cloud and their application stack sitting on another. And when you make all those calls across the internet, you pay egress, you pay performance. And so that's starting to rear its head in the generative AI space as well, that it's pretty clear that having the application stack sitting next to the foundational model is a huge advantage from both a performance and a price perspective. I'll just jump over to one more. I'll tiptoe on the enterprise side, and then I want to make sure we have time for questions. On the enterprise side, it's a different world, right? In the startup space, everybody, and I fully embrace this, is going fast, looking for mind share, first mover advantage, which I would expect everybody to do. On the enterprise side, there's much more concern around legality, around intellectual property, legal concerns of what's created, who owns it, where does my we've already gotten 3 or 4 questions on that major concern around data security. Where's my data going? How's it being used? I say this with all due respect to our competitor or other players in this field, is that if you're a startup and you're selling to the enterprise, if you don't have that strong construct around how you're going to segment their data and keep that out of a foundational model, it's just a non-starter right now. There's just so much concern around data privacy and where that's going. There's also, we're still in early days. There's still a whole ecosystem of tools that are really built around this space that don't exist yet. When there's security tooling that needs to exist. There's the decision of inference, which is a big one. And what I mean by that is I get a lot of questions on, again, I think everybody's looking at it from a litigation standpoint. And if I had a direct consumer model that spewed out something incorrect, or who knows what, did something that I wasn't expecting it to, and now I'm liable for whatever that model did. Under legal discovery, the question that freaks everybody out is, well, why did your model do what it did?
Oh.
And that's a really hard problem to solve, because to be able to articulate exactly why a model said or made the decision it did is not an easy task. And there's still, we're lacking tooling around that in the space. And most are leaning towards buy versus build. But as I mentioned earlier, the enterprise is much more interested in, I want the whole thing private versus a subset of the model private. So, we're, again, like, our sales reps would love to sell everybody their own version of Palm. But I think the appetite for that consumption would, when you see the cost and the overarching operational portion of that, it just becomes non-feasible at this time. And then the focus for enterprise, I think, too, is there's definitely been some eyes opened on, and I think the general populace is now understanding that, hey, the foundational models are going to be available to everybody. So that's an amazing function, but may not be unique in any go-to-market strategy. What is unique around the enterprise space is they may have massive amounts of corpus of data that are decades old that don't exist in the general corpus of information that these foundational models are trained on. So they have an opportunity to bring some niche functionality to market based on the data that they only have. But that itself is not a trivial task to go back through multiple silos, classification, look for IP issues in the training data. So that's where I see a lot of my work with the enterprises is the foundational model almost takes a back seat to, like, yeah, the foundational model, we got it. We know how we can apply it. What we need help with is parsing through years of data and understanding what we should be training the model on, what we shouldn't be training the model on, how would that surface, how do we segment it, how do we classify it, and how do we create pipelines to continue to keep that updated. So with that, we've got 15 minutes and there's a zillion questions. And then I want
bunch of questions. So let me start popping you with some questions. Tom Peck, I'm going to take people a little bit out of order here, but Tom, you got a question about sort of the enterprise landscape. You've got AWS, Microsoft, Google, of course, a number of different platforms. How do you pick and choose? So Tom, maybe you can further.
Hey, Josh, Tom.
Yeah, go ahead, Tom.
Oh, sorry. Hey, Gamil. Hi, Josh. Tom Peck, CIO at Cisco in Texas. Yeah, like most of us on the call, we've been experimenting with traditional AI for a long time. We have multiple cloud partners. We use your competitors. We're ideating around use cases on Gen AI, but we're really trying to figure out, what to do next. In the chat, you've got Code Whisperer, Azure AI, Vertex AI, co-pilots versus Duet. The calculators are confusing. You got to know the secret handshake. Some folks on the call may have strategic partnerships, which narrows it down to Google or otherwise. But when you're using all three, clearly you're the best. But how do we validate that? How do we navigate through that when you've got all the tools and some are GA and some are in private preview? But we're trying to figure out who to partner with. Any life advice on how to navigate through that?
Yeah, the truth of the matter is, and I say this a lot, like anything I say today is probably going to be out of date in a week. We're still in very early days of this market stabilizing. So there's going to be a lot of experimentation for the next probably year and a half within generative AI. I would say, from the early first steps, again, I think the enterprises have the correct mindset is that these foundational models, we're all understanding what they can do, and they're all going to be available to everybody that wants to use them. I think the bigger construct is to think about the data and security aspect of it. So if you're experimenting if you're looking at the different cloud providers, one is you want to make sure that the cloud provider is going to support both first party, third party, and open source models, because that's just going to be the future. Again, like I'm not trying to bash OpenAI in any way, but that's kind of the Achilles heel of OpenAI, is that they're building a business around access to the model. They're not a cloud provider. Now Azure is trying to mend that, by providing services through Azure. But as I mentioned earlier, that's going to be key. Like what you're going to have is an application stack that's going to be making calls to multiple models, sometimes larger foundational models for high level tasks, sometimes smaller, more efficient models just for some base language processing, or you name it. So I think that what I would be looking for in the early days is, okay, I want to make sure that if I'm going to be using generative AI, I'm going to have a choice in models, and I'm going to be able to land my application stack next to that model. And then outside of that, I want to make sure what are the data constructs around fine-tuning, embedding, accessing this model, so I can be assured that what I build is not going to be part of a training set in the future for some of these foundational models. I hope I answered that, but that's, ultimately, I think that's why there's going to be so much pressure on the open source solutions, and again, why we're big proponents of open source, is that, to your point, I'm been in the cloud space for a long time, so I'm also not naive to the fact that depending on who your end customers are, they may be asking you to be on Azure or GCP or AWS as a constraint of them using you. And again, this is where open source can be a great answer to that, because if you are today, in today's world with foundational models, again, and this is going to change, that if I want to be multi-cloud, that means I have multi-stacks. Let's just give an example of OpenAI and Palm. If I wanted to use GCP, and say I have a customer that needs to use GCP and a customer that needs to be on Azure, and I want to use generative AI, my stack's going to look different, because my prompt, the way these models respond, is very different on the prompting. So if on a GCP side, I've got to have some portion of the stack that's interpreting and responding with Palm. And then on the Azure side, I'd have a completely different portion of the stack that's working with OpenAI. And there's customers I'm working with that are trying to figure this out, load balancing between foundational models, and it's a hard problem to solve. Whereas open source allows you consistency across cloud providers.
Thanks, Josh. That's
no
actually very, very helpful, and a good answer, unbiased answer. So appreciate that.
No problem.
Great, thanks, Tom. Hey, Prith, you're offering a perspective here that we've been leveraging lots of data for free, Facebook, et cetera, for years. You want to offer in kind of why we should be feeding these big LLMs?
My point is that I know that people are freaked out about, oh, it's my data, and they're going to sort of take it all in the foundational model. But in the last sort of 20 years or 10 years, right, Google search became good in terms of quality and accuracy because you sort of tapped all the people who are doing some billions of searches, right? I mean, the reason you could do autocorrect on my search was because everybody was doing the search and I did it wrong spelling things. And I greatly appreciated the value we provided through this thing, right? So I think people are just completely freaked out, right? Going the other way. Hey, we'll not let you use anything. So my philosophical question is there a way for all of us to opt in to provide the data so that you don't attribute it to me, right? But we all benefit from the common knowledge that is going on. I mean, right now I feel there is just all foundational and only local, right? But if we can all pool our knowledge, this is how you did autocorrect on search, right? Is there any movement there to help collections of people to contribute so that everybody benefits?
It's a great question. Man, we could talk for an hour on this. It is a really interesting. Like the more I play this forward, it's very interesting, and you're seeing a lot of this right now. I don't want to name specific companies, but if you're privy to the space, you can see a lot of concern in both ways. You know, I've seen a lot of press lately on, you know, basically we've been talking about how data is the new oil for like 10 years, you know, 15, but now it's being realized in real time that, oh my gosh, yeah, my data is, to your point, very valuable because it's the corpus of the general understanding of these foundational models. So you're seeing some big companies that have large data sets that are publicly available to now kind of pulling back on, oh, wait a minute, you know, this is definitely valuable. I'm seeing it now realize of how valuable it is. So there's both dichotomies kind of going on at the same time. To your point, like there's how do we collectively, because that, I mean, at the end of the day, if all the information gets shut off, these foundational models are only going to be as good as a point in time because they're, you know, you need that continual information stream. At the same time, to the question you had is, I think what everybody's kind of noodling is, if contributing data, awesome. What's your return on that contribution? Like how do we
compensate for that?
Yeah. How do you compensate, or how do you recognize, or how do you know, what's the incentive for everybody to keep? And on the flip side of that is, again, like if data becomes a super valuable commodity, then if it overarchingly increases the cost of the foundational models, which increases the cost of everybody using the foundational model. So it's definitely nothing that we've figured out yet. Right? That's still, it's a conversation going on. And there's, you know, definitely data sets that are more valuable than others. And it's an interesting conversation to have. Like I said, I would love to whiteboard and go down this rabbit hole for an hour on like how we think we might do this in the future, but it's definitely something we're thinking about.
Yeah, great question, Prith. Kumar, you're asking about how to unlearn something once it's been learned into the foundational model, plus this sort of meta learning concept and incremental learning. Do you want to ask your question directly?
Good morning, and thanks for this very useful session. What I was trying to understand was especially, we were talking about the foundational model being frozen. So what I was trying to understand is, you know, as things evolve, you know, as, you know, changes happen, how do you sort of factor those changes into this model? Is it done to the adaptation layer, or is it something more fundamental than that? And the follow-on question was, as things change and, you know, as things evolve, is the concept of meta learning really helpful? I just was trying to get an understanding of how pragmatic it is in what you're trying to do. This is sort of the two questions.
Yeah, it's interesting. It's definitely, you know, there's a delineation between our direct-to-consumer and B2B. So BARD, our direct-to-consumer model, is being looked at as an entity like search. And so it's got to stay up to date, real time, you know, as much as possible. Even though the foundation that it's been trained on is frozen in all intents and purposes, right? But that foundational model is only there to construct or to provide the natural language processing and the contextual analysis. And what you're seeing with BARD is behind the scenes, you know, it's calling relative real-time information. It's that embedding process that I talked about, just at scale and a different motion. But that's the embedding portion is really what's in semantic search of embeddings is really what the differentiation is. That's how you keep control of this. Think about it. I'm trying to think of a good analogy. Like the foundational models already been trained. Think of it as a human perspective. The foundational models have already been trained up to have the contextual natural language processing and reasoning prowess of let's just call it a high school graduate, right? And that, but what needs to be added is, that's great. Let's just say you have a graduate intern that can parse through whatever you want from a data perspective. It's now, you don't really need to train that intern on how to interpret data anymore. They've already gone to school for it. What you need to do is augment them with the real-time information that you want them to parse through. And that's where it's very unique probably to each customer, and why it won't be part of the general corpus of the foundation, but why embeddings is so important. Because embeddings is basically handing that digital intern, like, here's the documents I want you to summarize. Here's the documents I want you to derive insight out of. Here's the documents that I want you to direct me to where I should be looking for whatever it is. And again, that's going to be specialized per use case, which is why it's not part of the actual foundational model, why you wouldn't train the foundational model on that, for two reasons. One is, again, like, if you were to train the foundational model on that data, the way a foundational model works is portions of that data can then be responded outside of that foundational model to someone else if it was a shared model. But also because normally the embedding data is going to change rapidly.
Yeah.
And so that allows you to not go through the fine-tuning process of weeks, of months every time you update your data. You're basically just saying, hey, intern, remember these docs? Like, here, add this page, or you know what, we're not using these anymore, use these. It's, again, probably a poor analogy. I don't mean, but
no, it helps to get the idea. Okay.
That's really the difference. And again, like, fine-tuning at scale that we're talking about, like, if you, we have fine-tuning, like, fine-tuning again is like how the model behaves. And so where we found fine-tuned POM is in a couple specific use cases. One is in the medical field, so MedPOM. So, you know, we really want the model to have the vernaculum of a medical professional. And in that case, we want to go that extra mile and fine-tune the whole model, but that's not trivial. That takes weeks and millions of dollars to do. And then the other area is cybersecurity, you know, because we have a lot of training data, you can imagine in that too, that we wanted to fine-tune. But unless unless there's a very specific need to have a model very precise in how it responds and functions, usually fine-tuning is there's not the return on investment you're going to get there.
So we're going to run out of time. So let me and I'm sorry, I'm not getting to everybody's question. Vishal, you asked a question about pricing, and specifically how to get started with an MVP around pricing. And maybe this is a good way to close and give some sort of recommendation, Josh, on how people can, you know, begin to build an environment of their own. So Vishal, maybe you could ask your question and then.
Yeah, no, I think it's right. So, you know, MVPs, POCs is one thing, everybody is doing them. Many organizations are starting to see, okay, how do I scale this? And I know it's going to be an it depends kind of a response, but I'm just curious if you can share any general, like, you know, pricing for these kind of models or usage of generative AI solutions compared to, let's say, traditional techniques we've all used, like, you know, we've used Dialogflow and Document AI and those kind of things. But now with this, any benchmark, any metrics you have, is this costlier, simpler, cheaper? I don't know. Anything you can share on that front?
Yeah, I'm just laughing because I'm literally getting pinged on this all day long by our sales organization. Like, how do we price this thing? How do we scope this thing? And unfortunately, like, it depends, because basically what these models charge for is in and out of tokens. So just think of it as words in, words out, right? It's just processing. And that's hard to model or give a rough estimate because it all depends on what you're asking the model and how you're asking the model. So when you hear about prompt engineering, you're basically surrounding a question with context in your prompt. And some of those prompts get very elaborate, and they can be thousands of characters long. So depending on how much you need prompting for, or how much you use prompting versus embedding or tuning, can sway your costs on a generative AI application pretty heavily. You know, like, I think most of us is an example, and I know we're running up on time, and I'd love to continue this conversation with you. It's been a fun conversation, so happy to do it again. But when most of us as laymen's are directly inputting our question to the model. Like, so if you're using Bard, you're going out to Bard and you're asking a question. So your prompt looks like the question you asked. But in application development, when you really want to get these models to do complex functions, you're probably surrounding it with not paragraphs, sometimes pages of prompting information to get it to act. And that's not editable by your customer. That's in the application stack. And so as I mentioned, every one of those characters in the prompt has a cost associated with it. And then depending on how often your application is asking for data from the foundational model can exponentially increase that too. So it's again, unfortunately, like it would depend, but
yep.
that's the starting point, is to look at how you're gonna interact with a model, and really how often and how big is that prompt, and how big is the response back from the model. Those are like the three variables.
So design remains an equally important character even in this.
Yeah,
thank
you.
Yeah, for sure. Thank you very much.
Hey, Josh, thank you so much. Thank you, everybody, for joining today. Sensitive to overstepping our time limit with you here. We have recorded the content. We'll share the slides that Josh presented, and stay tuned for all of that being summarized and sent out to all of you. Look forward to further conversations on this topic going forward. And Josh as well has offered to share his contact information, and we can model that or get that out shortly as well. So thank you all.
Thank you. I was enjoying it. Thank you.